Ever pondered the impact of climate change on trees' ability to absorb carbon dioxide? As if the current state of global warming wasn't concerning enough, recent research adds another layer of complexity to this crisis. It turns out, trees, the very organisms we rely upon to act as our natural carbon sinks, are battling to breathe in hotter climates. To understand this, we need to delve into the miraculous process of photosynthesis. Picture this. Trees, much like a well-tuned orchestra, conduct a symphony of chemical reactions using sunlight as their music sheet. They ingeniously convert carbon dioxide from the air and water into glucose, a form of sugar that gives them energy to grow. Oxygen, a byproduct of this process, is generously released back into the atmosphere, providing the very air we breathe. However, under stressful circumstances such as high temperatures or limited water availability, trees switch to a different tune, a process known as photorespiration. Instead of absorbing carbon dioxide, trees start releasing it back into the atmosphere. It's as if the trees are coughing instead of breathing. What's more, recent studies indicate that photorespiration rates can be up to twice as high in warmer climates, especially when water is scarce. This alarming revelation challenges the widespread assumption about plants' role in carbon sequestration. The reality is, trees and plants are currently absorbing only about a quarter of the carbon dioxide emitted by human activities annually. And as the climate continues to warm, particularly if water becomes scarcer, this percentage is likely to decrease. As we consider future climate scenarios, it's clear that the increasing CO2 levels, while theoretically beneficial for plants, will come with a significant trade-off. The warming world may render plants and trees less able to draw down that CO2, a factor that some models have yet to fully account for. This study also introduces a novel method for tracking photorespiration in trees. By examining variations in certain isotopes within wood, specifically in methoxyl groups, scientists can gauge the rates of photorespiration. Think of isotopes as different flavors of atoms, each with their own unique properties due to variations in their mass. In summary, trees, our natural carbon sinks, are struggling to breathe in hotter climates. The process of photosynthesis, which typically allows trees to absorb CO2, can switch to photorespiration under stressful conditions, causing trees to release CO2 back into the atmosphere. As the climate warms, this trend is likely to intensify, posing a serious threat to our efforts in mitigating global warming. It's a stark reminder of the delicate balance of our planet's ecosystems and the urgent need for action against climate change.